Hello, physiology. Well, so this is a supplemental video to your class. It's really not part of your material for your final exam. It's just me giving you some information about immunity, viral infection, because of this current COVID crisis that I thought would be, and the vaccine, that I thought would be beneficial for you to know before you leave this class, not so much because it's part of the course material, but rather for your own sake and all of us in general. It'd be good if we all understood the virus more more so, and how the vaccine is going to work. There's I hear so many myths running around out there that are just basically incorrect, and we kind of need to clear those up as knowledgeable physiologists. I think we can pass on credible information more so, especially after we've done a lot of immunity study in our course. And a lot of you have actually gone through microbiology as well, or are currently. Anyway, this is some helpful information for you, for your sake, basically. Okay. Well, first, let's just do a little bit of our immunity, review, a little bit of virus review, and then I'll go into the current virus and the current vaccine that's coming up here. Okay. So these virus things are, they're not living entities. They're just these little particles that contain DNA or RNA. You know, they're all different shapes and forms. They either contain DNA in them or an RNA or both. And with that, the DNA or the RNA, that's what they actually end up replicating. They actually end up using your cells to replicate that DNA or RNA, and then use that to replicate themselves. But they have to be in your cell, and they have to use the equipment, so to speak, of your cell to be able to reproduce themselves. They can't do it on their own. So a virus you can't put a virus in water and have it divide and prosper or proliferate on its own. It does not. It has to enter a cell. So it has to have a method of getting into a cell, and then it uses the cell's chemistry to create more copies of itself. So if we were to have a regular cell here, let's just draw one of our own. We have a cell here. Oh, and we'll just have a little, we'll just make a little virus particle here. Virus particles they all have different methods of getting into our cells. They can't do anything to us outside the cell. Unlike bacteria actually damage our cells from outside the cell. They proliferate in our body fluids. They produce toxins that are damaging to the cells and the cell membranes and our cells. So they damage our cells from the outside of the cell. Whereas viruses, they have a method of getting into the cell, and once they're inside the cell, then they release their RNA or their DNA into the cell, and then that RNA uses the cell's chemistry, enzymes and chemicals, to basically create copies of that virus. You know, the different pieces. it creates all the different pieces of the virus, and then actually has um, programming to have the cell put those pieces together into a functional virus. And so basically, that cell has become a virus manufacturer. It's a little virus making company, and it makes many, many, many viruses and particles, and ultimately dies. It fills up with viruses and dies, breaks, and then releases those viruses, and those viruses spread out and infect all the other cells around it. Same way. So a virus just spreads from cell to cell to cell, and each of those cells is making many more copies of that virus. Now, we mentioned in physiology that there is this thing called interferon that a cell puts out. A cell that's infected with a virus puts out interferon, releases interferon. And that's a good name because it's a chemical that interferes with a virus's capability to replicate in another cell. So this cell is putting out the interferon. The interferon helps to protect other cells around it from viruses in general replicating in those cells. It interferes with viral replication. So that's one of our defenses against viruses. Well, lots of times, like your cold virus and your flu virus, they replicate faster than our interferon works. So we end up with the cold. We end up with the flu. Mm-hmm. Well, that's the thing. The viruses themselves are not living entities. They're just particles. How do they kill the cell? Well, they basically ultimately fill up the cell, kill it, and the cell breaks. We get, during that whole process of the virus replicating, we have a body immune response to it. We've talked about in physiology that primary response that comes from being exposed to foreign antigens. So a virus will have, on its surface, it has these proteins. It's got a protein coat, and it's got protein like different types of I don't know what to call them. In this case, in the current virus, it's the spike protein. It's on the surface of the virus itself. And these proteins here, they are not the same as our cells. They're different. They're different proteins. And our immune system can recognize that those are foreign proteins. So we call those antigens. Remember, we had a definition of an antigen was a substance. It doesn't have to be a protein, but it's typically a large protein. It's a substance that generates an antibody response in our body. An antigen generates an antibody response. Often there's an antibody response and there's a T cell response. There's a specific immune response. We make antibodies that are specific for certain pathogen antigens, and we make T cells that are specific for certain pathogen antigens. Recall that the virus is the pathogen. So the virus or the bacteria, that's the pathogen. The pathogen. And the antigen is the components to the pathogen that generate the immune response. The components, the antigen is the components of the pathogen that generate the immune response. Okay? All right. Well, the vaccines in general, thus far, have been of this type or this strategy. Typically, they, like the flu vaccine, they take the pathogen, in this case a virus, flu virus, and they destroy it. You know, they always say they kill it. Well, remember, it's not alive. So they destroy it. What they do is they typically heat it, or they expose it to chemicals. Either way, they take that pathogen. We'll just take our. It could be a virus or it could be a bacteria. Either way, let's do a bacteria. Either way, we'll put our antigen on the surface of our. Let's just make it a virus, I guess. It's kind of a virus day. So there's our virus. It's got the RNA or DNA inside. There's our antigen protein on the surface of the virus. They heat it to the point that it destroys the virus or the bacteria. What it does is it breaks it up, breaks it into pieces. Just breaks it into pieces and destroys the RNA and the DNA in there. It's all destroyed. It's not possible to survive the heat they expose it to. But these little antigen proteins survive. And those are then put into the vaccine. Basically, the broken, attenuated virus or bacteria is then the destroyed version of the virus or the bacteria is then put into the vaccine, given to you in the shot, and then those antigens stimulate the immune response, the same immune response in your body that would occur, that same primary response, development of clone of plasma B cells and memory B cells, a whole clone of them, clonal selection theory, that can create, all of them can manufacture and create a specific antibody for that particular antigen protein or that antigen. And so now your body makes antigens. It makes antibodies. Your body makes antibodies to that antigen. And those antibodies, they actually stick like this. You know, if I wanted to be precise, they stick to the antigen, and they connect they connect the antibody to the antigen. Sorry, and that exposure there to that foreign antigen causes the development of those antibodies, and that clone of plasma B cells and memory B cells that can produce that particular antibody. So you get this big giant population of, say this is flu virus H1N1. So you got this giant population of H1N1 memory B cells that can make the antibody to the H1N1 flu virus. So that when you come in contact with the actual virus and it gets into your body, you actually get infected, gets into you, your body has already gone through the primary response. Remember, that takes weeks. That primary response takes weeks. Primary response could take weeks. So if you were in your primary response and you get that virus, that flu virus, it's going to take weeks to get that antibody development. And in the meantime, the flu virus is infecting you and making you sick. So the whole strategy of the vaccine is to put you through the primary response to get you into the secondary response, so that when you do come in contact with that flu virus or whatever it is, that virus, you've got a whole population, a whole army of memory B cells that can create the antibody specific for that virus. And that only takes hours. That secondary response happens within hours of infection. So you get infected, it spreads a little bit, proliferates a little bit, and your body responds so quickly that it clears up that, destroys that virus before it really gets a chance to spread and actually really make you sick. You may get a very mild version of that flu virus, a mild version, or you may not feel anything, stuffy nose or something. But it protects us from getting the full-fledged um, virus. Okay, that's how that works. The symptoms that you feel with a virus, with the flu, many of the symptoms you feel, like a fever or a runny nose, congestion, a muscle aches, that is actually those particular symptoms, not the sore throat, but those kind of particular symptoms, those are actually not the disease causing that. That is your immune response. That is your natural immune response. It's, say a runny nose is trying to get rid of, it's making the mucus run out so that you're getting rid of the particles. You're expelling particles. So those are methods of, it's like your natural healing immune response. So you can get those. The point here is that you can get those with sometimes in mild ways, you can get those with vaccinations because it's not the disease that you're going through when you get a little fever or muscle ache or something. It's not the disease, but rather it's your immune response. So it's actually a good thing. It's showing you that, oh, your body is actually developing that immune response for that, whatever you've been vaccinated for, and it will work in the future then. You will be protected in the future to that particular pathogen. Okay, so that's kind of a myth that a lot of people think they get the flu shot and then they have a little fever and muscle aches and runny nose, and they think the flu shot gave them the flu, and it didn't actually. It generated the immune response, the natural immune response. Now the sore throat, that actually is the virus or the bacteria that's damaging the cells there. They're actually killing the cells there, and that damaged cells is what gives you the pain. Pain receptors are sensitive to damaged cells. Pain receptors are sensitive to materials that come out of a cell when it has been damaged. It gives you the sense of pain. So a sore throat, that's the disease. You typically don't get a sore throat from a vaccine. Okay, that's a general vaccine. Now, what else would be good for us to know about that? Well, I also mentioned that T cells can be produced. You can get a specific response, specific immune response by also producing T cells to that particular pathogen. So your body creates T cells, cytotoxic T cells that can directly kill a bacteria, destroy a virus by contact. They have the capabilities to destroy by contact. Remember, they put a hole. Those cytotoxic T cells, they generate a pore in the surface of the bacteria or the virus. They poke a hole in it, and then they also inject granzymes. They also inject enzymes into that bacteria that destroys the DNA. So it kills it by destroying the DNA, but it also can kill it by poking a hole, because then fluids flow in through those pores, and the cell, if it's a bacteria, it's lysated from that. Okay, so the granzymes can destroy the DNA, which would kill the cell or the virus, and the pores allow materials to diffuse in and lysate, burst the cell. Okay, so we've got a specific immune response in two ways. We've got an antibody created, we've got cytotoxic T cells, and that's what those vaccines generate. Now, the current virus, the COVID-19 virus, is got this. It's an RNA virus. In other words, it's containing RNA rather than DNA, and it has these. It has different components. They're really simple structures. They usually only have 4 or 5 components to them. This one's got these spike. No doubt you've heard this. It's got these spike proteins on the surface. These spike proteins on the surface, and this is how the COVID virus actually gets into your cells. It uses those spike proteins to keep all of this kind of simple. It uses those spike proteins to get into your cells. So the current vaccine's strategy has been to target those, the spike proteins, to prevent those viruses from getting into our cells. If you can neutralize the spike protein, you can prevent that virus from getting into your cell. And if it can't get into your cell, it can't infect you. Can't make you sick. Can't destroy your cells. So that's what they've done. Now that virus particle has been coded for by the RNA that's contained within it, correct? So the RNA that's in that virus was used at one point in time inside a cell. That RNA was used inside a cell to make all of these components of this entire virus and then program them to be put together into a functional virus particle. All right, so this was used. So what they've done, now the messenger RNA, that's the messenger RNA. Messenger RNA. What they've done is, for this current vaccine, is they have synthetically created the section of the messenger RNA molecule, synthetically created the section of the messenger RNA molecule that will generate the development of these spike proteins only. So it's a synthetic version of a portion of the messenger RNA molecule that is being generated, or that's being put into the vaccine, and that's what's injected into you. It's not the virus. It's not the messenger RNA that makes the whole virus. It's not possible for that synthetic portion to generate the COVID-19 virus in your body. It's not possible. So you can't get COVID-19 from the messenger RNA vaccine. Can't give it to you. And so here's how it works. So when you get that messenger RNA, that synthetically created messenger RNA, that's what they were working on in those pharmaceutical companies, that they put it in, they put it into your muscle, they inject it into the muscle. The messenger RNA is it's highly volatile. It doesn't last long. That's why they have to keep it frozen, super frozen, prior to any kind of injection. Once it gets into your muscle, now it's taken in by the cells, and it's going to degenerate within a day or two, couple days. It degenerates, but in the meantime, it's taken in by those muscle cells, and it's used by the muscle cell chemistry to create these spike proteins. And those are what the antigens are. Those are the antigens that are going to stimulate an immune response. Okay, so now what we have in us is we have this messenger RNA. It's in our muscle cells. and it's coding for the production of these spike proteins, which are then presented on the surface of the cell. They're put onto the surface of the muscle cell, and now that's exposed to the environment, our body environment, and our immune system recognizes that those spike proteins that are on the surface of our muscle cells, for gosh sakes, are not part of our proteins, self proteins in our body. They're not. And it recognizes that. And so our body goes through the primary response to generate the antibodies and the cytotoxic T cells to those spike protein antigens. And it's going to be the same antibodies generated there that can bind to the actual virus particle spike proteins when you're infected with it. They will bind to it, and they will render those spike proteins, they'll neutralize them basically, so they cannot be used by the virus to get into our cells. So you see, you get your vaccine. After a week or so, you've developed these antibodies to the COVID-19 spike protein antigens. You've got this giant population of B cells, memory B cells and plasma B cells. They're cranking out antibodies that as soon as an actual virus particle gets into your body and gets into a cell, and then that cell presents those particles, your body has a response within a couple hours, producing, secreting, millions of antibodies. The same response that would have happened in 1 to 2 weeks in the primary response happens within hours. You see this giant, it's even bigger. The secondary response is even larger than the primary response. And plus it's many times faster, right? Hours instead of weeks. So now that virus is just not going to have a chance to replicate much in your body. You may get infected, and it may be there for a few hours, but it's going to be cleared up fairly quickly. It's not going to have a chance to proliferate. That's how it works. It's a fabulous design. The one thing that's going to come out of this that's positive is that this is going to lead the way to other vaccines in the future. These, and rather than having to put an attenuated actual virus or bacteria into the body, you just synthetically make a messenger RNA molecule that can produce one of the non-infective antigens to the virus or bacteria. See, these spike proteins. They help the virus to get into the cell, but they're not the infective part of the virus. That is the RNA. The RNA is what causes your cells to make a whole bunch of viruses. It's not the spike protein. The spike protein just gets the virus into your cell. You see? So if you make these spike proteins, they can't possibly infect you. They have no capability of doing that. They can't do anything to you. But they do generate the same immune response that the actual infection would cause. And now you've got the same immunity that you would have had you gone through the disease, but you just had the shot instead. And so that whole primary response that it just put you through, you might get a little fever, or you might get a sore muscle there, or you might get a runny nose or something. I'm not sure exactly what it's going to be with this one. Probably some of the same things there. But it's going to be so minor, and it's not the infection. It's not the thing that can hurt you. It's the immune response instead. So, they say that this Messenger RNA, another advantage, the messenger RNA vaccine acts much quicker than the previous traditional vaccines. It works faster, and so it will help folks from becoming these asymptomatic infectors. Basically, that's the real problem we have. Is we have folks who it's a week or two or three before the actual from the infection to the symptoms. I have heard from somebody I know 3 weeks later from a known infection. So in that time period, that person didn't know they were infected and they're just passing it on to whomever, right? There's the problem we have. So now with the vaccine now, that within an hour, a person gets infected, within hours it's rendered non-infective. So the person really isn't going to become contagious. And we get enough people around us, surrounded us, that have been vaccinated. You get what you call herd immunity. The people that do have the virus are so far apart, so spread apart, so few in the herd that the spreading of the virus really slows down. And if we get enough, we can, like they've gotten rid of smallpox through vaccines. They could, with an aggressive approach, they can get rid of the disease on the planet even. Okay, they practically had polio beat. Almost, didn't quite get there. That's that. But so people just need to be, educated on this, so they're not so afraid of taking the vaccine. Read about it yourself. It's all over the internet. Okay. Anyway, well, thanks for listening. See if I forgot anything. Anyway, that should help you with generalized immunity. Yeah, it can help you with your flu shot too. Now the flu shot, here's the thing with the flu shot. While I'm here, the flu shot, they destroy that flu virus. I mean, like I say, they don't mess with it. They kill it. They break it into pieces. They heat it to the point it's not possible to survive. And that's what's put into your body, a broken up, destroyed virus in that vaccine. So then your body has the immune response to it. And you have the antibodies and the memory cells and the T cells and the plasma B cells and so forth. Now, where the flu vaccine gets a bad rap is they develop the virus in eggs. An egg is a cell, right? You need to develop viruses in a cell. Well, an egg is a giant cell. So they develop in eggs. And if a person potentially is allergic to eggs and they take a vaccine, then they could have a reaction to it. It's not the vaccine they reacted to, it's the fact that they're allergic to eggs. So I suppose somebody who is allergic to eggs should not take the virus. I mean, the vaccine, excuse me, the vaccine. Now, the other thing is that sometimes, a very small component of people, very small, have a reaction to the preservative that the vaccine is put into. So when you get a flu shot, they take the fluid for the vaccine for your shot. They take it from a common container where there's a lot of it contained in a preservative. So they take the amount they need to give you the shot. And so there's occasionally, very, very occasionally, I haven't even heard of anybody ever, but occasionally somebody has a reaction to the preservative. So now the answer to that, if you're worried about that, the answer to that is you can actually get shots, you can request shots, vaccines that are not put into a preservative. So they're a single unit shot that have been made by itself in the syringe, vial, for one person, one time shot, and there is no preservative in it. You see, and you can avoid that by doing that. We all got the flu shot like that, or a flu shot. We could get rid of the darn flu. Anyway, there you go. That's what I know about these things here. And good luck to you, and hope all is well. Stay safe and sound, and good luck on your final.